Hi, I'm Lety, and this is a right triangle. It has side lengths of A, B, and C. These side lengths are all related to each other through a formula called the Pythagorean Theorem. You can use this formula to find the length of A, B, or C, using the length of the other two. But we've already learned how to do this, so now we have to ask, why? Why does that work? Well, there are many proofs and demonstrations you can use with all kinds of math. One we will look at today uses the areas of triangles and squares to prove the theorem. The area proof of the Pythagorean Theorem. The first thing you have to do is make another triangle identical to the first. Then rotate it and flip it over to the right. Now make two more triangles and line them up like this. Now we have a square. Let's find its area. Each side is made up of one A and one B, so each side is equal to A plus B, and the area of the square is A plus B times A plus B. Now let's find the area again. This time you might notice there's another smaller square in the middle of the first square. Its area is c squared because it is made up of all of the c sides of the triangles. If you add the area of this square to the area of all four triangles, you will get the area of the square. The area of one triangle is equal to 1/2 times the base times the height, or 1/2 times a times b. If you multiply that by 4, you'll get the area of all four triangles, 2ab. Add c squared to get 2ab plus c squared, the area of the square. Both a plus b times a plus b and 2ab plus c squared are equal to the area of the square, making them equal to each other. If you solve for c squared, you'll get a squared plus b squared is equal to c squared, a formula also known as the Pythagorean Theorem. If you're still not convinced, I have one more fun visual demonstration of the Pythagorean Theorem. So let's go. This is a right triangle with sides labeled A, B, and C. We've cut out 3 squares using each side of the triangle. Square A, Ron square, has an area of A squared. Square B, Hermione square, has an area of B squared. And square C, Malfoy square, has an area of C squared. If we look at the Pythagorean theorem, it will tell us that A squared plus B squared is equal to C squared. Therefore, the area of Ron and Hermione squares combined should be equal to the area of Malfoy square. Let me demonstrate. If A squared plus B squared is equal to C squared, then Hermione and Ron should have the same amount of M&Ms as Malfoy. That was pretty fun. And now we've learned 3 very important things. Why the Pythagorean theorem works, how to prove and demonstrate the theorem using area, and the math can be delicious.